When you're ready with the conversion, I can put it in. Can anyone give us the first one, 64? 6 raised to x equals? Good. So remember, we do not simplify bases, please. Two numbers are equal, and they have the same base. X must equal, yes, the exponents must equal. Good. So we found the answer. Good. Can anyone convert 56? But there is another way of writing 9 to 1/2. Right. So then x equals the square root of 9, which x equals 3. Remember, this number must be greater than 0 because it's applied to, log is applied to it. This number can be anything. Log is not applied to it. But this number must be strictly greater than 0. Okay, very good. Back to page 736. Let's look at a couple more equations and a word problem here. I'm pretty sure we did all these problems, but let's refresh our memory with 25. 32 raised to 2x minus 3 equals 2. And also refresh our memory with 36. 4 raised to 3x minus 7 equals 32 raised to 2x. So let's work on these problems for a minute. Can anyone give us the starting point for 25? Right. I will have to replace 32 by 2 to the 5th. And the right-hand side is 2. And from here, copy the base. What happens to the exponents? Multiply them, right? 5 gets distributed here. So 5 raised to 10x minus 15 equals 2. We are not simplifying bases. Here's how we think about it. Two numbers are equal and they have the same base. What has to happen to their exponents? What do I have to write? Yes, so 10x minus 15 must equal 1. Or 10x must equal 16, or x must equal 16 over 10, and I have to simplify by 2, so x equals 8/5. Any questions here? Okay, 36. How do I write the left-hand side? 2 squared raised to power 3x minus 7. And again, the same thing, 32, which is 2 to the 5th, everything to 2x. And what do I write next? 2 to 6x minus 14 equals 2 to 10x. Very good. So the exponents have to be the same. 6x minus 14 must equal 10x. You can subtract or whatever you want to do. Negative 14 equals 4x. So x equals negative 14 over 4 or negative 7/2. How come that I don't have to state a restriction here? What type of equation is this? Or 25? What type of equation? Exponent, right? Exponential equation. Exponential equation. Do we ever state restrictions for exponential equations? No, that's true. Never. Good. Let's look at a word problem. Cheese production in the United States, problem 39, on page 736. Cheese production in the United States is currently growing at a rate of 3% per year. The equation y equals 8.6 multiplied by 1.03 raised to x models the cheese production in the United States from 2003 to 2009. In this equation, y is the amount of cheese produced in billions of pounds. Y, billions of pounds. And x represents the number of years after 2003. So 2003 represents x equals 0 for 2003. Perfect. Part A, estimate the total cheese production in the United States in 2007. How much is x for the first part of the question? So 4 years. So then y will be, what type of, by the way, what type of equation is this? I'm sorry, what type of function is it? We know so many now. We know linear, we know absolute value, we know square root, we know the cube root. We know linear, as I said, we know exponential, we know logarithmic, we know cube root, square root. Which function is this? What is it? Exponential, correct, because the variable is the exponent. Perfect. So 8.6 multiplied by 1.03 raised to power 4. And I got 9.7 roughly what? Billion of pounds. Good. And now for 15. For 2015, how much is x? So how much is y? How much did you get? 12.3 roughly. Billion of pounds of cheese. Good. Going back to section 12.2. Okay. We are given the function from problem 38 on page 726. We are given f of x equals 7 divided by 2x plus 4. We're asked to find f inverse, and we are told f is 1 to 1. So let's find f inverse, please. For 7 over 2x plus 4. Can then anyone get us started? You mean f of x by? Very good. Next step. Good. And now you are going to for? Exactly, because y becomes f inverse. Correct. How do I solve this? What is it? What type of equation is it? A linear equation cannot have the variable in the denominator. Okay, here's your hint. But I would like you to remember when you look at something like this, I would like you to automatically say, oh, I know, this is a exactly, specifically, proportion. What do we do with the proportion? So please cross multiply and find y. Remember, if an equation has x or the variable in the denominator, it cannot be linear. Can anyone dictate the next step, please? If you want to write it like that, I accept it. Yes, we should see it and then distribute. That's fine. So 7 equals. I'm solving for y. Next step. Now here's a question for you. Will you simplify this x with this x? No, because we know chapter 7. X is a factor here, but this x is not a factor at the top. Excellent, thank you. So the final step is I just replace y by what notation? But inverse. That's what we are trying to find. And of course, I will write x not equal 0. Very good. Here's one more, problem 40. Same question, please. We are given a function that is x minus 5 to the third. We're asked to find f inverse. Please go through those 4 steps and tell me what to write when you're ready. Can anyone give us the first step? Good? Very good, excellent. Yep, that's the only way. I have to apply the cube root. So what do I have next? Very good. Excellent. Any questions? Any questions? Okay, back to page now 717. Let's say problem 3 on 717. We are given f of x, which is x squared plus 1. We are given g of x, which is 5x. We're asked to find the sum, the difference, the product, the ratio, and their domains. So we want the sum, the difference, the product, and the division or ratio, and domains. Let's think about this for a minute. Can anyone remind us what we need to determine first? Every time we're asked to find the sum, difference, product, and ratio, what is the first thing we have to determine? Of f and g, and then the what? Excellent. So first I have to find the domain of f, then the domain of g, and then I have to find the common domain. Why? Because this will be the domain of 3 functions for sure, always. Which functions? Sum, difference, and product, yes. I meant to write this. Good. Can anyone give us the domain of f? Okay, so if I give you this function and I say evaluate it for 1, can you do that? Good. Then I say evaluate for 2. Can you do that? Then I say evaluate for -3. It's quadratic. It has a minimum at 0, 1, right? It's defined everywhere. It's a parabola, opening upward, having a minimum, right? So it's x squared lifted up 1. So what is the domain of x squared plus 1? Right. All polynomial functions are defined everywhere. Remember, if you don't see a square root, if you don't have the x in the denominator, and if you don't have a log, so far from the functions we looked at, it's all real numbers. There is no division by x, there is no square root, and there is no log. Good. Now what I don't know is what's going to happen with the ratio. But for these 3, I'm done. So let's find now the sum, the difference, and the product. So I want to find f plus g, f minus g, fg, and finally f over g. So let's find them. And please write the definition. Can anyone dictate the definition of this first? Yes, please, write that first. Write f of x minus g of x for the second and for the third and for the fourth. So you don't make a mistake when you replace them. Can anyone dictate the first one? x squared plus 1 plus 5x, and I will rearrange it. It's not, yes, plus 5x plus 1. I will rearrange this, although it's not going to make a big difference. Okay, but we normally present all polynomials in descending order. Okay, can anyone dictate the first step of the second one? So then I will write x squared minus 5x plus 1. Good. Now the third one. And this is it. Good. I'm finally at the last one, the ratio. I reached that step. Good. What is the domain then of the ratio? From the common domain, which happens in this case to be everything, I must remove what value of x? Good. So then I am ready to write a domain of this function. Excellent. I want to add another question here. Here's my question. Find f comma g and g comma f, and also f comma g of -1. So please give me the definition of f comma g. By definition, this means? Very good. What do I replace this by? Very good. So then this is f of 5x. Remember, f says whatever squared plus 1. How do I continue? So, what do I write? But how much is 5x squared? Any questions? Now I want g comma f. First g of f of x. Indeed. Now g says 5 times whatever. How do I write that? 5 times whatever. Very good. Which is 5x squared plus 5. Any questions? Now I'm asked to find f comma g of -1. Since I have the function f comma g, why reinvent the wheel? I'm right here. I'm asked to evaluate this function for -1. All I have to do is just plug it in to find f comma g of -1. Can anyone dictate? But -1 squared is 1 times 25 is, and 25 plus 1 is? I would like us to decompose 34. Please decompose 34, function h of x, into an outer and inner. Can anyone give us an inner? 3x plus 4. Now this becomes a number. Do you all agree with this? Good.
There's a beeping noise out there.
Oh, yeah, that's fine. I'm sorry, I didn't hear it. Do I need to check my hearing?
No, I think it's like one of those classes over there. It's just fine.
Oh, I'm sorry about that. Good. Any questions on chapter 12? Anything that you worked on, anything that you have questions on? What if I ask one more question? Find the inverse of 2x plus 1 and graph them. So find f inverse and also graph both on the same coordinate system. 2 minutes, and then we start chapter 7. And we go backwards. It would be disappointing if you wouldn't do very, very well on this test on Wednesday, because we reviewed everything for 4 hours. So we are finding the inverse of 2x plus 1, and then we graph both on the same coordinate system. Can anyone give us the first step for finding f inverse?
You want okay, so y equals +1, then replace so x equals 0 plus 1, subtract 1 plus y equals 1,
Do you agree with x minus 1 divided by 2 as the inverse function? Okay, now I would like to graph this first. So I have f of x or y equals 2x plus 1 when x is 0, y is 1, and that's the ordered pair. Now I want when y is 0, I have 0 equals 2x plus 1. I move 1. So x equals? Good. And the ordered pair is -1/2, comma 0. Why did I do that? Because it's a linear function. I only need the x and y intercepts. So I have these 2 points to plot. 0, comma 1, -1/2, comma 0. Do we agree with this? Okay. So 0, comma 1, -1/2, comma 0. Please write on the function somewhere. Good. Now, I refuse to determine more points, but you will tell me which points I have to use in order to graph the inverse. I have to graph the inverse now. Can anyone give us two ordered pairs that will help us graph the inverse? Yes? Yes?
1 comma 0.
Correct. So this point is reflected here. So it has to be 1 comma 0. And the other one is?
3 comma 1.
The other point is? One more time. 0, negative 1/2. Very good. Perfect. Now, what else do I have to graph before I graph this function? I have to graph y equals x. Why do I graph y equals x again? Because I know that these two functions are symmetric with respect to y equals x. So therefore, this point where the function crosses y equals x, the inverse must cross as well. So this is the f inverse, which was x minus 1 divided by 2. Any questions? Very good. Back to chapter 7. On page 500, problem 44. 5x to negative 2 minus 3y to negative 1. Everything divided by x to negative 1 plus y to negative 1. 2 minutes. Of course, we're asked to simplify. Oh my goodness. Okay, very good. Oh, yes. I didn't turn on the video from the beginning. I just forgot. So, but I do have this, yes. But I'm going to post the whole thing, yeah. Can anyone get us started? Good. So 5 over x squared minus. Very good. And plus. Very good. That's a starting point. Excellent. So let's work on this. What will be the next step? Can anyone just say what we need to find? Don't dictate anything else. Yes. Very good. Yes. I have to find the least common denominator, top and bottom. Not at the same time, of course. When you get the chance, when you finish with the numerator, move on to the denominator. Can anyone give us the least common denominator for the numerator? Very good. And the adjustments, anyone? And? Very good. And the top, can anyone give us the top up here? Very good. Excellent. Perfect. Now, can anyone give us the LCD for the denominator? And the adjustments. Y and X. On the top,
X, Y, X.
careful, or Y plus X. Yeah, let me write it as Y plus X for everyone to see, and then we'll switch it. I said if you see two variables, I'm okay if you don't write restrictions, because you're not going to see two variables before Calc 3. So I'm fine. If you can just say, assume all denominators not equal to 0, and I'm fine. You don't have to do anything else. Then I know that you have to state restrictions, and that's all I care about. So then the top is 5y minus 3x squared over x squared y multiplied by, right, which is xy over, now I can switch it into x plus y, and I will arrange this in descending order, sort of, because I consider x and y. So then I will put a negative outside, 3x squared minus 5y over x squared y. I should have simplified before writing it again. So then what do I have to do? I can get rid of something. xy and x and y. So the negative stays, the numerator, which is 3x squared minus 5y, and now what is the denominator? And you do not have to distribute. Please do not distribute. So x here and x plus y here. Any questions on complex rational expressions? They are complex because there are operations with fractions at the top and operations with fractions in the denominator. Yes? Okay, should we look at another?
Yes.
Okay, let's look at 20. Five divided by a plus 2 minus 1 divided by a minus 2. Everything divided by 3 over 2 plus a, and plus 6 over 2 minus a. 2 minutes. Can anyone just say something about it? What would you do first, or where will you start, or anything? At the? Okay. Okay, that's good. Now for this one, I expect you to write restrictions because it only has one variable. Okay, the least common denominator for the top. Very good. There are two different factors. All different factors have to be present in the LCD. Excellent. Thank you. So then the adjustments at the top of those two. One more time, even if you find the least common denominator correctly, I cannot give a lot of points. If you write 5 minus 1 at the top, it's 0. So the adjustment on 5. Very good. The adjustment on 1. Good. Now please dictate the numerator. 5a minus 10 minus a minus 2. Excellent. However, I cannot do the same thing with the denominator just yet. Why? Because the first denominator, first of all, is not in descending order. And the second one has an even bigger problem, not just the not descending order, but it has a negative leading coefficient. So then I will have 6 divided by negative a minus 2. Of course, I have to state that a does not equal, right? So then I have the numerator, I can simplify it. So then it's 4a minus 12 over a plus 2a minus 2. But I have one more step to write for the denominator. What is that? It's 3 over a plus 2, but then minus 6 over a minus 2. And only now I can find the LCD. And I will factor out the top 4. So a minus 3, a plus 2, a minus 2. Now I can find the LCD for the denominator, which is, right, indeed, a plus 2, a minus 2. And the adjustments now. Can anyone dictate the top? 3a minus 6. Careful. Minus 12. This problem had a lot of work because the denominator, at least one denominator in the denominator, was twisted. And furthermore, not just that, but it also had a negative leading coefficient. So now I can copy 4, a minus 3 over a plus 2, a minus 2. And I will multiply it by a plus 2, a minus 2 over 3a minus 6a, negative 3a, and minus 18. I can get rid of something that I already stated restrictions for, and those two go away. And they're these. However, 4, a minus 3, and I will pull out what from the denominator? Very good. And I have a plus 6. So negative goes in front. Do not distribute. Do not do anything. Just state one more restriction, a not equal negative 6 and a not equal plus or minus 2. And this is the correct answer. Any questions?